மேம் நீங்க மெசேஜ் மட்டும் போட்டுருங்க ஜூம் ஃபுல் ஆயிடுச்சு அப்படின்னு சொல்லிட்டு
Okay.
யூடியூப்ல ஜாயின் பண்ண சொல்லுங்க.
YouTube live is on.
Okay, sir. Shall we start, sir?
Yes, sir. Yes.
1 minute, sir. I'm starting, sir.
Okay, sir. Sure.
Yeah.
Okay.
Good evening to all the dignitaries, respected resource person, faculty members, and participants joining us from across the globe. On behalf of MEASI Institute of Information Technology, I warmly welcome you all to this Day 2 online international faculty development program on emerging frontiers in generative AI and deep learning from vision to language. Today, as we gather on this virtual platform to share knowledge, inspire ideas, and engage with global perspectives, let us begin the session on a serene and spiritual note. To invoke divine guidance and serenity, I now call upon Mr. A.K. Mohammed Gauss, Assistant Professor, to render the Kirat. Let us begin the academic gathering by seeking the blessings of the Almighty. Over to you, Gauss, sir.
Sir. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم ألم تر كيف فعل ربك بأصحاب الفيل ألم يجعل كيدهم في تضليل وأرسل عليهم طيرا أبابيل ترميهم بحجارة من سجيل فجعلهم كعصف مأكول بسم الله الرحمن الرحيم لإيلاف قريش إيلافهم رحلة الشتاء والصيف فليعبدوا رب هذا البيت الذي أطعمهم من جوع وآمنهم من خوف. صدق الله العظيم. Thank you, sir.
Thank you, sir, for the spiritually uplifting recitation. Ladies and gentlemen, to formally set the tone for today's program, I now invite Dr. M. Revati, Associate Professor, who will be delivering the welcome address, and she will also deliver a brief, insightful introduction of today's distinguished resource person, Dr. M.V. Aishwarya. Please, ma'am.
Yes, sir. Good evening to one and all present here. On behalf of MEASI Institute of Information Technology, it gives me great pleasure to welcome you all to this second day of 5-day faculty development program. At MIIT, we strongly believe in continuous learning and staying updated with emerging technologies. And this FDP is a step toward enhancing our knowledge in the rapidly growing fields of generative AI and LLMs. It is my privilege to introduce our distinguished speaker, Dr. Aishwarya, Associate Professor and Head of the Department of Artificial Intelligence and Data Science at Agni College of Technology. Dr. Aishwarya completed her bachelor's and master's degree in Computer Science Engineering at RMK Engineering College and later earned a PhD Computer Science and Engineering from Hindustan University in 2021. Dr. Aishwarya has published over 50 papers in SCA Scopus and UGC Index Journal and conferences and has authored 12 national and international books covering artificial intelligence, machine learning, green computing, and computer vision. She has contributed to SCA indexed book chapters published by Taylor and Francis Journal, published in 12 Indian innovation patents, along with receiving a design patent. With an impressive 13 years of teaching and industry experience, her areas of expertise include artificial intelligence, machine learning, human-computer interaction, and image processing. We are truly honored to have such an accomplished and inspiring expert with us today. I once again welcome each one of you to this FDP, ma'am. The session is over to you, ma'am. Thank you.
Thank you, ma'am, for a warm welcome and the thoughtful introduction of our resource person. It is now time for the most awaited part of today's program. We are deeply honored to have Dr. M.V. Aishwarya with us. Ma'am, kindly proceed with your session, ma'am.
Good evening to one and all present here. Is it audible, sir?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yes. Very good evening to one and all present here. Today's topic would be generative AI and large language models, LLMs. Myself, Dr. Aishwarya MV, Associate Professor and Head of the Department, Artificial Intelligence and Data Science, Agni College of Technology, OMR, Chennai. So let us move on to the AI hierarchy from general intelligence. From general intelligence to specific models. So what do you mean by AI? Artificial intelligence is a broadest field, and the goal is to create the systems that mimic the human intelligence. Machine learning, it is a subset of AI systems learn from the data without explicit programming. Deep learning, it's a subset of machine learning. It uses the neural networks with many layers to learn complex patterns. Generative AI, it is a type of AI focused on creating the new content or data. So these are the AI hierarchy, which is a subset. Generative AI is a subset of deep learning. Deep learning is a subset of machine learning, and the ML is a subset of AI. This is the AI hierarchy, which explains the general intelligence to the specific models. So coming to the generative AI. So what is generative AI? We are going to create something new. So it refers to a class of AI systems designed to create the original content. So the original content may be text, images, code, audio, video, and even the 3D models. Instead of simply recognizing or classifying the existing data, generative AI, it produces a new data that resembles the human created output. It creates original outputs. It can write essays, generate artwork, compose music, create the new product designs, write functional code, or simulate the voices and conversations. It learns from massive data sets to understand the underlying patterns, the relationships, and the structures. Once trained, they use this knowledge to generate the new high-quality content that follows the similar patterns. And it is different from discriminative AI, which focuses on identifying, categorizing, or predicting the outcomes. Example, is this image a cat or a dog? Or will this customer buy the product? So this generative AI aims to create something new, such as a brand new image of a cat that has never existed before. So this is the concept of generative AI, where we create something new. So we use a generative AI to create new things, and we'll see how it is going to work, how the generative AI works. So it has three phases. One is the training phase, the generation phase, and the creativity mechanism. So the training phase. So the model is fed with massive data sets. So the data sets may contain the text or the images or the audio, etc. And it learns the relationships, the patterns, and the structures within the data. And it uses the techniques like the transformers, autoencoders, and neural networks. The second phase is the generation phase. The user uses a prompt. It provides a prompt. Example, the prompt may be, example could be write a poem or design, give a car design, generate a car design. So the model samples from the learned patterns and then it predicts the next word, a note, or a pixel. And this process continues step by step to create the complete output. The third one, creativity mechanism. So the output is new and original and it is not copied from any other training data. So the creativity comes from how the model recombines the learned patterns in unique ways. It doesn't think like humans, but it generates results based on the probabilities. And this is how generative AI works. Coming to the input data layer. What would be the input data layer? It could be large data sets which contains the text, images, audios, codes, etc. Coming to the neural network layer, you are going to use different kinds of learning models like GANs, VAE, RNNs, transformers. They are all the deep learning models and it extract features and learn the representations. The third layer would be the pattern learning layer. It identifies the relationships, learns the context, structure, and style from the data. The next layer would be the generation layer, where you generate or produce the images or audios or new text. And it uses the decoding or the sampling or the latent space manipulation. The next layer would be the feedback and the refinement layer, where it gets the feedbacks from the user. It is used for fine-tuning and reinforcement signals, and it improves the accuracy and quality over the time. So this is how your generative AI works. So you train on the large data sets using the neural networks, and you learn the patterns, and the output is generated, and the feedback and refinement is done. Next, we are going to the diverse landscapes of generative AI. So what do you mean by this? We are going to learn about the different types of generative AI. One would be the text-based, image-based, audio-based, video-based, and mixed multimodal-based. So these are the 5 types of generative AI. We are going to learn one by one. The first one would be the video generation. So what is video generation? What do? You give the text and you convert into the video models. So we would see some of the examples here. Advanced models such as Sora and Runaway can create the short videos from the written instructions. So these are used for, where do you use it? It is used in cinematic previews, animation, advertising, simulations, and creative storytelling. So what would be the input here? Text. And what would be the output? Video. So your short instructions or written instructions from text is being converted into short videos. This is the video generation. The next would be the text generation, LLMs. So what would be the different examples? The models like ChatGPT, Claude, and Llama. It can generate human-like text, answer the questions, write the stories. It can translate languages, and it can chat with you, engage in conversations. And they understand the context and the semantics, making the powerful tools for the communication and automation. The next one would be the image generation, text to image models. So what would be here? The input would be the text and the output would be the image models. So what are the tools used for image generation? Examples could be DALL-E, Midjourney, Stable Diffusion. It converts the text descriptions into the artistic images. And these models can be used in marketing, advertising, digital art, and product prototyping. The next would be audio and music generation. Your text will be converted into the audio models. So systems like Music LM and Stable Audio can compose, generate the sound effects, music, or create the voice-like audio from the prompts that you give. And they are valuable they are used in applications like film production, gaming, creative music applications, and virtual environments. The next would be code generation, AI coding assistants. The examples AI models would be the GitHub, Copilot, CodeLlama, and Replit Code. So it can optimize the code, it can generate and debug and optimize the code. They improve the developer productivity by assisting with some syntax or some real-time problem solving. The next is we are going to see about the historical milestones in the generative AI. In part 1 and part 2, we are dividing the historical milestones in generative AI. So the part 1, we give a brief history, the early days. In 1950s, we call it as the foundations of AI. Alan Turing, he proposed the Turing test as a benchmark for the machine intelligence. The next would be 1960s to 1980s. Rule-based AI systems were developed. So early programs like ELIZA conversion using predefined rules were developed. Although not true generative AI, they demonstrate the first attempts at the machine-generated language. In 2000s, the rise of statistical machine learning. What would be the different techniques that were developed, like support vector machines, SVMs, and random forests become dominant. In 2012, deep learning breakthrough AlexNet was found. The success of AlexNet in the ImageNet competition, it triggers a deep learning boom. The next is the historical milestones in generative AI part 2. From 2014, it was called as the modern era and the introduction to GAN. GAN is generative adversarial networks, and it was a model where two neural networks used to generate high realistic images. And this was a biggest and the major milestone for creating the image synthesis and for creating the AI. From 2017, transformer architecture revolution has begun. And the paper called as the Attention is All You Need introduced the transformer model, which will be seen in detail in our PPT. This architecture enabled the efficient parallel processing and it has become the foundation for all the modern LLMs. In 2018, the birth of pre-trained LLMs began. Google releases the BERT and OpenAI releases the GPT-1, showing the large-scale pre-training dramatically improves the natural language understanding and the generation. And that was the mark where the LLM era has begun. In 2022, the ChatGPT goes public. So the OpenAI launches the ChatGPT, bringing many conversational AI to all the users, and it was widespread success among the global adoption of generative AI across the industries, entertainment, and in everyday life. So, is it a perfect storm, and why now? Why do we use it? Because it has massive data availability, increased computational power, and the algorithm advancements. So massive data availability it has created large amounts of unprecedented amounts of text, image, audio, and video. And this data serves as rich training material, enabling the AI models to learn many complex patterns and behaviors. Then modern GPUs and TPUs and cloud computing allowed parallel processing, and this hardware acceleration cuts the training time and boosts the model performance. Coming to the algorithmic advancements, the development of the transformer architecture modeling by using the attention mechanisms instead of recurrence. This made the training more efficient, scalable, and capable of handling long-range dependencies, fueling today's a powerful language and the multimodals. Coming to the key terminology at a glance, what is GAN, VAE, transformers, and prompt engineering? GAN is generative adversarial networks, where it is used to create a realistic image and synthetic data using a two-network system. The two-network system was generator versus discriminator. It is used to create the realistic images. Variational autoencoders were called as the VAEs. It compresses and reconstructs the data using a latent space. And these were used for smooth transformations and for generating the variations. Coming to the transformers, it was a modern neural network architecture, and it was the foundation of LLMs like GPT, Claude, and Llama. Coming to the term prompt engineering. Effective prompts to guide the AI and improve the accuracy, style of the generated output. These were the different key terminologies that were used: GAN, where, transformers, and prompt engineering. So prompt engineering gives prompts to guide the AI. Transformers used attention mechanisms, which was the foundation of LLMs. VAE, it reconstructs the data and was useful for smooth transformations. And GAN, it was a two-network system used to create the realistic images and the synthetic data. Coming to the future of generative AI, fully multimodal AI systems, stronger reasoning and high accuracy, hyper-personalized AI models, deep integration across the technologies, AI agents that act, plan, and collaborate. So first is the fully multimodal system. It will seamlessly combine the text, images, audios, and the 3D data in a single unified system to make the communication more natural. The next one is the stronger reasoning and higher accuracy. The AI will possess improved logical thinking, mathematical reasoning, and problem-solving abilities, reducing the errors. Hyper-personal AI model, they are in needs for the individuals and the organizations, work style, the domain knowledge, and providing tailored outputs and recommendations. The deep integration across the technologies. So the AI will merge with the robotics, IoT, smart systems, autonomous vehicles, and the digital twins. Driving, automation, the real-time decision making, and large-scale optimization. The AI agents that act, plan, and collaborate. So it will not only generate the content, but it also perform tasks, interact with the tools, collaborate with the humans or the intelligent agents or the co-workers. The next is we are going to see about the key concepts in generative AI. Coming to the diffusion model, it generates the image by starting from pure random noise, and iteratively it is going to refine into a meaningful image. So they learn the process of denoising step by step, producing high resolution outputs, and they are in Stable Diffusion, Midjourney, and DAL-E3, and are currently the most popular models for the image generation due to their stability, creativity, and quality. So we could see a training image, a data, which is being refined step by step. A pure random noise image is being sent to a diffusion model, and a new image and a generated image is got as the output of the diffusion model. You could see the two kinds of diffusion. One is the forward diffusion and the reverse diffusion. The next is tokenization and embeddings. So tokenization, what does it do? It breaks the text into the smaller units called as the tokens, words, or subwords. So AI will process this complex language efficiently. So it breaks the text. Whatever text you give, it is going to break it as tokens. Tokens are always called as subwords. Embeddings. It converts the text, images, or audio into the vectors that captures the meanings and the relationships. For example, car and vehicle, they have similar embeddings. And these representations will allow AI to understand the context, semantic similarity, and deep relations between the concepts. So as you see a diagram, example, I give a sentence, write a poem about the moon. It is being converted into small words. So tokenization. The output of the tokenization, these words are being converted into numerical factors, and then AI model gives you the output. So AI allows you to understand the context and the semantic similarity and the deep relations between the concepts. Sorry. The prompting technologies, it is very essential to guide the AI correctly. So we are going to see the different kinds of types of prompt engineering in the slides, in the next slides. Coming to the fine tuning and the instruction tuning. So this fine tuning, it will adapt a pre-trained model using the new data sets. Example, it can be a financial text data set or a medical or a legal, and it is going to adapt a pre-trained model to a specific domain using the new data sets. So fine tuning can be done. The instruction tuning trains the model to follow the human-like instructions, so that you can have, it will be very helpful in clarity, and these techniques may make AI more specialized, reliable, and useful for industry-grade tasks. The next would be regarding the safety, alignment, and the RLHF. Generative AI must be safe, ethical, and aligned with the human values. Regarding the safety, it is preventing harmful and misleading outputs. Regarding the alignment, it ensures AI behaves very responsibly and follows the rules. RLHF is the reinforcement learning from the human feedback. So what happens here? Human reviewers rate the model responses and helps the AI to learn better behavior. So this improves the it enhances the user's experience, and it improves the trustworthiness. So next is the synthetic data and the future applications. So it uses generative AI to produce the fake but the realistic data for training the models when the real data is limited, or when it is sensitive, or when it is expensive. So it is used in autonomous vehicles, medical imaging, robotic simulations, smart cities, and IoT. Synthetic data accelerates AI development while protecting the privacy. So what would be the additional key concepts in generative AI? The key concepts would be the diffusion model, the tokenization and embeddings, the prompting techniques, the fine-tuning and instruction tuning, safety, alignment, and the RLHF. The synthetic data and the future applications. So as we have seen, what is a diffusion model? It is going to generate the image by converting your random noise into pure noiseless outputs. Next one, tokenization and embeddings. So it is going to represent the input data as tokens and the numerical vectors. Prompting technique, it gives effective prompts. It crafts the effective prompts to guide the generative AI models. Fine-tuning and instruction tuning, it customizes the pre-trained models to give some specialized task. Safety, alignment, and RLHF, it ensures the system behaves with guidelines and follows set of rules ethically. Synthetic data and future applications, it generates the training data and enable the new AI-driven systems. These all were described in the previous slides in detail. The next is, we are moving into the large language models, LLMs. So what is large language model, LLM? They are the advanced deep learning models to understand the process and generate human-like text. So they are built using the neural networks, and they are pre-trained on massive text data sets such as books, articles, websites, and code to learn the grammar, semantics, reasoning, patterns, and the world knowledge. They are built using the neural networks, especially the transformer architecture, enabling them to capture the complex patterns. And the primary learning objective is to predict the next word or a token, which is in the sequence, which allows them to produce the content-aware responses. So what is the objective? What is the use of LLM? They are designed to understand the process and generate human-like text. And they are advanced deep learning models. So why are they called large? Because it has extensive training data. It uses massive number of parameters. It uses high computational requirements. It requires a large context understanding, high capacity for knowledge storage. So coming to the massive number of parameters, it contains billions or even trillions of parameters that learn the patterns from the data. And these parameters allow the model to store structures, relationships, facts, and reasoning abilities. Extensive training data. They are trained on the data sets collected from the various books, research papers, websites, code repositories, and other text resources. High computational requirement. So it demands a powerful hardware, a GPU or a TPU clusters running for weeks or months. The scale of the computation requires further emphasis how large these models are. Regarding the large context understanding, it can process long sequences of text at once, allowing them to generate more meaningful responses. The next is high capacity for knowledge storage. It stores a significant amount of the world knowledge learned during the training, enabling them to answer a wide range of questions accurately. So, what is a core mechanism? It is the next token prediction. It's a simple but yet profoundly powerful. So, predicting one token at a time forms the foundation of this LLM, all the LLMs. In statistic probability in action, the models, it calculates the most likely the next word based on the patterns that they have learned from the training data. Emergent intelligence through complex reasoning, the contextual understanding that naturally emerge. The autocomplete analogy, it is sophisticated autocomplete, but with deep understanding of the grammar, the logic, and the facts. Coming to the architecture of the transformer. Let's see the attention mechanism, the innovation that changed everything. So it focuses on the relevant input features, self-attention for the word relations, the multi-head attention for the rich understanding, captures the long-range dependencies efficiently, foundation for the model LLMs. The first one would be the focus on relevant input features. So what would be the different input features? The attention is, it allows the model to focus on the important words or tokens so that it can improve the understanding and the accuracy. Okay. The next is self-attention for word relationship. So it computes how a word is related to another word, every other word, the sequence, and assigning a relevance score. So this model helps understand the context very deeply. The next is multi-head attention for rich understanding. The different multiple heads runs in parallel, each learning a different type of relationship. It can be a long range context or a syntax or a meaning. It can be anything. So all the heads run in parallel with the different kinds of relationship. The next is, it captures the long range dependencies efficiently. So it can connect distant words or concepts without a sequential processing, unlike the RNN. The foundation is, the next is for model LLMs, the key mechanism behind the high quality text generation, the reasoning, translation, and coding capabilities in today's LLMs. The attention is behind these, the text generation, reasoning, and the translation and the coding capabilities. The next is speed through parallel processing. So coming to the parallel processing, unlike the RNN and the LSTM, that reads the input one word at a time, the transformers, it uses the entire sequence at a time. It processes the entire sequence at a time, and it removes the bottleneck of the sequential computation. And massive reduction in training time. So it uses the matrix operations on GPUs, thus reducing the training time from weeks to days or even hours. The next is efficient scaling across the GPUs and the TPUs. It distributes the data across the multiple GPUs to extreme large databases and the model sizes. So it gives you efficient scaling across the GPUs and TPUs. And exploring the gradient problems, because the transformers do not rely on step-by-step recurrence, They avoid the gradient degradation, which is very common in the RNN architectures. The better utilization of the modern hardware. The design aligns perfectly with the modern architectures. It can be either GPU or TPU, giving huge speed and gains the efficiency. Coming to the encoder part. In encoder, we have the input. And we are going to talk about each block inside the encoder. So input, the raw text is being converted into tokens and it is fed into the network. We have the embedding layer where the token is converted into a vector representation so that the model understands the semantic meaning. Then comes the positional encoding. Since the transformers do not process input sequentially, they need positional information. So the layer adds the position-based features so that the word, it will know what word comes first or the next. Then multiple encoder blocks. Each block contains the self-attention, the feed for word network, the layer normalization, and the residual connections. Stacking the several layers, which helps the model understand the deeper and complex patterns. And the encoder output will be a final output, which is a representation, contextual representation of the entire input, the input sentence. So this output is passed to the decoder. Next comes the decoder. What would be the target input? It will be the correct previous output tokens during the training or already generated tokens which are used as the input. The next would be, we have the embedding and the positional encoding together. Just like the encoder, the target sequence get embeddings and the positional encodings. Several decoding blocks are there. Each decoder block contains a masked self-attention. What does it mean? It looks at the previous tokens and prevents the model from cheating by the future words. The next block is the cross attention. It connects the decoder output with every encoder output. And it helps the decoder focus on the relevant parts of the input sentence. The next would be the feed-forward networks and the normalization. The linear layer, it converts the decoder output into the raw scores for each word, vocabulary word. The softmax converts the scores into the probability and the highest probability becomes the next token output. So all these blocks we were explaining about. So we were talking about the input, the target, the softmax, the linear, the positional encoding, embedding. We were talking about the different blocks of the encoder, the different blocks of the decoder, and how this architecture works. Coming to the LLM data sets for training. We were talking about the LLMs. We are now talking about the LLM data sets for training. How do you train? There is a common crawl, the internet's largest text archive. This is one of the largest open source web data sets containing the web pages since 2008. Millions of URLs are available from the blogs, the news websites, the forums, the articles, and the general web content. It offers natural, real-world examples of the language. It provides huge linguistic diversity, covering the different styles, the topics, and the cultures. It plays a major role in helping the LLM learn and understand the contextual, grammar, and the patterns. It also contains the dynamic data and helping the models understand the current trends, the common knowledge, and the real-life scenarios. It is almost all the modern LLMs. It is used by almost all the modern LLMs, which includes the Gemini, the Llama, GPT. And it requires extensive cleaning because the raw web pages, it can contain the broken pages, the harmful content, or duplicates or ads. After processing, it gives a broad and versatile data set essential for the general purpose intelligence. This is about the common crawl. and which is one of the biggest open source web datasets. The next is Wikipedia. As you all know, it provides a high organized and well-structured articles, making it easy for the models to learn the factual information. They are continuously updated, ensuring that the dataset contains relevant and the current data. And it covers millions of topics, including the science, the history, geography, technology, culture, and more. And it is written in consistent formal tone, helping the LLMs learn the clarity. It exists in multiple languages and contains multiple citations and references, and making it a trusted source of factual accuracy. It learns the hierarchies of informations, improving the summarization skills. It has low noise when compared to the raw data, and it reduces the need for filtering. The dataset is almost used by every LLM because of its quality, the reliability, and the knowledge density. The next is books, deep, long-form knowledge and reasoning. Books, generally, they offer a long-form structured content which helps the LLMs. It provides thousands of public domain literary works from classics to poetry. It also, many LLMs also train on the licensed commercial book datasets, which covers the fiction, non-fiction, and the technical fields. The non-fiction book strengthens the model's knowledge in areas like science, psychology, self-help, and education. Books expose models to the richer vocabulary and the complex sentence structures. They allow LLMs to learn long-range dependencies, improving the ability to stay coherent across the paragraphs. And particularly, it is beneficial for tasks like summarization, explanation, and creative writing. They are usually high quality and cultured, making them a valuable dataset component. Coming to the curated datasets, ensuring clean, safe, high quality data. So the raw internet data, it contains the toxic data or low quality content. So a heavy filtering is required. So automated tools detect and they remove these duplicates, the malwares, the sentences, the broken sentences, and the random text. Toxicity filters the violent, hateful, harmful language, and the content is screened for misinformation and extremely unreliable sources. High quality subsets of web data like refined web, the pile, C4, are used after the filtering. So these clean data sets makes more safe, accurate, and more aligned with the human expectations. And it also reduces the training cost by ensuring only meaningful and useful data enters the model. So what are the steps to train your own LLM? Number 1, define your goals. Number 2, select the right LLM. Number 3, prepare your data. Number 4, choose a training approach. Number 5, select the right training infrastructure. Number 6, train and evaluate the model. Number 7, deploy the fine-tuned model. So let's look at the steps one by one. How do you train your own LLM? Define your goals. You have to have what problem it is. Clearly specify what problem you want the LLM to solve. Then identify whether you need summarization or question or answers, coding or domain-specific task or text generation. And determine the model performance. What would be your accuracy? What is the expected model performance in reasonability or speed or accuracy? Decide if your model must be open source or private or enterprise grade. Define the target audience and the use case. Who are the target audience? The students, the business, and the researchers. Understand the budget. Set the success metrics. Clarify the goal is full training, fine tuning, or lightweighted training like LoRa. Document everything. Document the overall project scope to maintain the direction. So you have to define your goal and you have to be very clear and specify what problem you want the LLM to solve. This is your first step. Choosing the right LLM. So you are going to choose between the basic models. What would be the basic models? You want to choose your GPT Neox or Llama or MPT or any specialized models like Code LLM, Medical LLM, etc. You are going to consider about the model size based on your GPU budget. You are going to choose about the open source options like Llama, Mistral, Falcon, GPT-J, and Bloom. And check about the licensing restrictions. Check about your which preferred language you want or the domains. Ensure the model supports your preferred languages. Then compare on the benchmarks on Helasweg, GSM, 8K, Truthful, QA, MMLU. Look for the models with strong community support and documentation. Decide whether you need a decoder or encoder or encoder-decoder. As we have seen in the architecture, decoder for only chat or encoder for classification or encoder-decoder for translation purpose architecture. So select a model that aligns the best with your application requirements. This is your step 2. Next is preparing your data. So you are going to gather all kinds of text from reliable sources like datasets, websites, logs, or user chats or documents. Then clean the data. How do you clean the data? We will remove the noise. We are going to remove the noise, the duplicates, then formatting errors, irrelevant text, everything are being removed by cleaning the data. Then apply the tokenization. What do you mean by tokenization? Your text is being converted into tokens. Okay, so more model readable tokens. Then remove the toxic or the harmful content to create a safe training data. Split the data. You're going to split into the training, validation, testing partitions. Then you're going to use the structured formats like CSV or text corpus or JSON for better processing. And if you need any metadata, you can add the metadata, like if needed, like labels, the context tags, the categories, etc. Then you have to ensure that the dataset covers the diverse situations. Then if it is fine-tuned, prepare the instruction response pairs or the chat style data. So preparing your data would be the third step. Next step is choosing a training approach. So the full training. It trains from the scratch and fine-tuning. Adjust a pre-trained LLM for your task. The most efficient one has to be chosen. The next one is the instruction tuning. You are going to give the instruction or teach the model to follow the instructions more reliably. Then you are going to use the reinforcement learning from human feedback for your alignments. Then you can use LoRa or QLoRa for low-cost defined tuning using the fewer parameters. Then prompt tuning or prefix tuning can be given. You can modify the prompts instead of modifying the model. Then you can choose the supervised or the unsupervised methods depending on your data availability. Then you're going to select the multimodal training. If your model should handle images or audio, then you are going to decide on the checkpoints to monitor the progress during the training. Then select the right training infrastructure. So you are going to determine what kind of infrastructure you are going to give, whether you will train on cloud GPUs like AWS, GCP, Azure, Paperspace, and you're going to choose the right GPU type like A100, H100, V100, RTX 4090, etc. You're going to estimate the cost. So estimate the required VRAM based on the model size. Then use the distributed training if your model is very large. You are going to decide on the cloud infrastructure or the on-premise service. You decide between what you're going to choose. Ensure you have fast storage and I/O to prevent the bottlenecks. Then use frameworks like Hugging Face, Transformers, PyTorch, DeepSpeed, etc. You apply optimizations such as mixed precision for the faster training, FP16, BF16, etc. Then you are going to plan for continuous monitoring. You are going to track the errors and you are going to log in. So you are going to select the right training infrastructure. This would be the next step. Train and evaluate the model. So start training. So your selected configuration and the data set. You're going to start training. The monitor metrics like perplexity, accuracy, and loss curve. You can perform the validation to regularly check if the model is overfitting or underfitting. Then you can use the evaluation benchmarks like Blue, Rogue, MMLU, Truthful QA. Apply the checkpoint to avoid the losing progress. You have to adjust the hyperparameters for better performance. Use the early stopping if the model performance stops improving. Then collect the errors and the failure cases, and then evaluate the model performance on the real world test prompts. Then you're going to deploy the fine-tuned model. So convert the model into an optimized format for the deployment. It can be any of the optimized format like GGUF or Int4 or ONNX for deployment. And then you are going to host the model on the cloud platforms like AWS or a local server or Hugging Face. Then you are going to use the APIs to integrate the model with your web services or applications. And deploy using the inference engines like TensorRT, VLLM, faster transformer, and we are going to apply the content filtering and the guardrails, and you're going to implement the monitoring to track the errors and the user interactions and the latency. You're going to optimize for the cost using the batching or the GPU scaling, using the quantization or the GPU scaling or batching, and continuous updates through ongoing fine-tuning or the dataset expansion. Then you are going to document the entire deployment setup for the maintainability. So these were the previous steps. So you are going to define your goal. You are going to select the right LLM, prepare your data, choose a training approach, then choose the infrastructure, then train and evaluate the model, and deploy the fine-tuned model. So these are the 7 steps to train your own LLM. The next is pre-training. We are going to talk about the technical breakdown. The pre-training is the first and the largest stage of the LLM development, where the model learns the patterns. It is going to learn about the general language patterns, and it uses the unsupervised learning, meaning the model reflects directly from the raw text without explicit labels. The objective is next token prediction or masked token prediction depending upon the architecture. It requires massive data sets. So it can use Common Crawl, Wikipedia, books, filtered corpora, etc. And the pre-training, it teaches the grammar, the patterns, the word knowledge, and the semantic relationships. It usually determines 80 to 90% of the model's capability. So the model parameters get updated through trillions of gradient descent steps. It can also produce a general purpose model that can be later be fine-tuned or instruction tuned for specific task. So this is the most computationally expensive part of your entire LLM pipeline. So pre-training, this is the first and the largest stage of your LLM development, where it teaches, it requires the massive data sets, then it determines the model capability, then it produces a general purpose model, then it's computationally expensive part of the entire LLM. Coming to the computational cost, the GPUs, the infrastructure, and the money. So these requires high performance GPU clusters, A100, H100, TPU v4, TPU 5. It needs thousands of GPUs running in parallel for weeks or months. And the cost includes the GPU usage, the storage, the cooling, and the labor. And the cost, example cost of GPT-4, GPT-3, all the cost is being given here. And the large tech companies, it relies only on the distributed training frameworks. Examples could be the JAX or Megatron LM or Ray or DeepSpeed. It runs, the training runs can fail. So the redundancies add to the costs. And the companies use generally the supercomputers or specialized AI clusters, and it must support high bandwidth networking to avoid the bottlenecks. And only a few organizations worldwide can train the frontier LLMs from the scratch. This is about your computational cost, about the GPUs, the infrastructure, and the money. What about the energy use and the environmental impact? So it consumes millions of kilowatt hours of electricity. It can emit hundreds of tons of carbon dioxide depending upon the energy source. It requires massive cooling and constant power, increasing the environmental load. It can run continuously for months, so contributing to high carbon footprints. And it has the environmental concerns have pushed the companies towards the renewable power data centers. Efficient fine-tuning models, LoRa, QLoRa, it cuts the energy consumption for downstream training. And it is moving towards, every industry is moving towards the green AI practices, such as the quantization, the pruning, the hardware efficiency, etc. So this is about the energy use and the environmental impact. So it consumes millions of kilowatt hours of electricity. So the different language sizes, model sciences are being depicted here. Coming to the parameters, what they are and why they matter. So they are the internal values, the weights that learns during the training to recognize the patterns. And it represents a tiny mathematical connection that model understand the meanings, the relationship, and the context. And the more parameters give the model higher capacity to store. And the parameters determine how deeply the model can analyze, predict, and generate the text. And the larger parameter spaces allow the models to capture the semantic relationships and the long-range dependencies. A model with few parameters may underfit and fail to understand the complex queries. Ultimately, the parameters acts as a model's memory plus intelligence storage, influencing the overall capability. So they are the internal values the model learns during the training to recognize complex patterns. It can recognize the complex patterns. It can deeply model and analyze, predict and generate the text. Then it can capture the subtle semantic relationships and the long-range dependencies. The next is why bigger models perform better, because they have more capacity to store the world knowledge and and improves the accuracy across the task. They perform significantly on complex reasoning, the mathematics, and the coding task. They handle multi-step prompts, and they handle ambiguous data more reliably. Then they excel in few-shot and zero-shot learning, and they show stronger emergent abilities. They generate better across various different domains like medicine, law, science, and they can maintain longer context windows, enabling them to follow long conversations. They produce more coherent, fluent, and accurate responses. But however, they require more compute, the memory, the training time, and the cost. Everything would be more. So examples of the models and the sizes. Let us see some examples. GPT-3. So large-scale a model known for strong creativity and the understanding, general language understanding. GPT-4, this is an AI model with advanced reasoning, coding, and the multi-model capability. The Llama 3 series, we talk about the 8B, 70B, 400B plus. So 8B would be a lightweight model for consumer hardware and edge devices. 70B would be like it is a balanced model with GPT-4 abilities in many tasks. 400B plus, it is designed for large scale enterprises and research research grade industries. And smaller models offer the speed and low cost suitable for local or mobile deployment. The mid-size models like 70B, it gives a sweet spot between the accuracy and the efficiency. The trend in modern AI research shows the bigger models and the smarter training. So model families with the different sizes allows the developers to choose on budget, we can choose on hardware, we can choose on use case. So these models excels in professional tasks like math, coding, research, law, etc. So coming to the current LLM landscapes, the major players, coming to the open AI, GPT 3.5, 4 and 4.0, OpenAI remains the market leader in the general LLMs, and they deliver the state-of-art reasoning, coding, and multi-modal abilities. And it is excellent for instruction following and conversational quality. It powers the powerful tools like ChatGPT, the Microsoft Copilot, and various enterprise solutions. Then it is used for real-time multimodal input-output, which could be a text or a voice or a vision. Then it supports various API integrations and the various enterprise offerings. And it is also adopted because of the reliability, capability, and the ease of the integration. So OpenAI model sets the benchmark for all the AI evaluations. And it is continuously improved through the RLHF and the safety model alignments. Coming to the Google, Palm 2 and Gemini, it emphasizes the multimodality. It means it is a combination of text, images, audio, and video. And it performs strong performance in the translation, coding, and reasoning. It advances the multimodal capabilities, further integrated across the Google Workspace, Android, and search. And it is used to build on multiple devices with different sizes. And it models excellent tasks where context, understanding, and image reasoning is being done. The large integration of the ecosystem like Android Gemini apps, Bard, Docs, Gmail, and it is heavily responsible AI, and it focuses on safe deployment. And it is designed for global scale using the Google's TPU infrastructure and a strong research foundation through the DeepMind and the Google research collaboration. Coming to the Anthropic Claude 3 series, Claude 3 examples could be Haiku, Opus, Sonnet. So they are known for long context windows and often exceeding 200K plus tokens, and strongly focuses on safety, ethics, and controlled outputs. And it excels in structures, document analysis, then business tasks, legal tasks, and it is built with the constitutional AI methodology for the safer behavior. It is preferred in industries where safety and consistency matters. And it can uptake in finance, legal, and heavy domains, and recognized for a clear and professional responses. And the current LLM, coming to the LLM landscape, open source, Meta, Llama 2 and Llama 3. They are Llama 2 and 3 are transformed the industry by offering the high performance open source. Llama 3 examples could be the 8B, 70B, 400B, B+. It computes with the GPT-4 level models, and they're optimized for fast inference even on smaller GPUs. And the ecosystem through, it has a strong community ecosystem through fine-tuning tools and the Hugging Face. And many local AI assistants are being, Llama powers many local AI assistants, chatbots, and it supports multilingual capabilities and advanced reasoning. And it is widely used in commercial AI development and also in academics. And it is also available under a license that accelerates the enterprise adoption. The next would be the Mistral AI, Mistral and Mistral, known for higher efficient models with the exceptional performance per parameter. It uses a mixture of experts called as the MOE architecture for speed and accuracy. It releases, the open source releases have outperformed large models from ideal, which is ideal for real-time deployment, and the model runs on consumer GPUs and the edge hardware. And adopted, and this has been increasingly adopted by the various research groups and startups. And this transparent licensing encourages broad usage, and it is positioned as a strong competitor to the closed source giants. And these are usually ideal for the real-time deployments. And the open source releases have outperformed very larger models. Coming to Cohere, this is designed purely for enterprise environments and privacy, known for world-class embedding models, which can be used in search, RAG, and knowledge systems. And this is optimized for the corporate workloads, and it is not generally used for chat, and it is secure on private cloud deployments, and it provides domain-specific tuning solutions and used in financial research, analytics sectors. And it is a leader in embedding-based AI systems and designed with high scalability and data governance in mind. Coming to the mechanism of tokenization, so they can understand the raw words directly. LLMs, they cannot understand. They just take the text and they convert into the tokens, which are the numerical representations. So this token can be a single character or a subword or a full word. Example, tokenization must be broken into tokenization, so making rare or longer words easier to process. So this tokenization enables the model to handle millions of unique forms. And the subword tokenization, it helps them more deal with new words, multilingual text, misspellings, and the methods include the BP, they call it as a byte pair encoding the word piece and the sentence piece. So each token is being converted into a vector by using the through an embedding layer, which we have seen earlier, where which the model uses to understand the meaning. And it reduces the tokenization process, it reduces the vocabulary size, and making very and training faster, cheaper, and more efficient. So it improves the model's fluency, coherence, and the ability to generalize to unseen text. The next is sampling strategies. So after the model predicts the probabilities for the next token, we determine the sampling strategies. It determines which token to choose. So greedy decoding is a technique where it picks the token with higher probability every time, but often repetitive outcomes, resulting in repetitive outputs. The beam search explores several sequences at once to find the most optimal one, which can be used for slow process, but it can be used for translations. The temperature scales the probability distribution. So lower temperature means more deterministic. Higher temperature means more creative and diverse text. Next, top K sampling. It restricts the choice to the top K, most likely the tokens, preventing the low quality outputs. The next is top P, nucleus sampling. It chooses from the smallest set of tokens whose combined probability is greater than or equal to P, and it adapts dynamically. These methods, they balance the creativity and the coherence depending upon the use case, whether you write storytelling or you write the coding or chatbot, it depends. And these methods balance between the creativity and the coherence. So combining all these top P, the temperature, and the top K, it produces the most natural and human-like text. So this is a mechanism that turns the mathematical probabilities into a meaningful, fluent language. The next is the loop. So from tokens, you are going to convert into a coherent paragraphs. So the input prompt is first tokenized, and then this token is being converted into the numerical token IDs where the model can understand. That these tokens are passed to the model, and then it tries to understand the context and the meaning. And then it computes a probability distribution for the next possible token. And a sampling strategy then decides which token to select from the probability distribution. So a sampling strategy can be any one of the following, like greedy or temperature or top K or top P. Once selected, the new token is being appended to the existing sequence. And it predicts the most likely token continuing the cycle. So this loop repeats token by token, building sentences, paragraphs, and full paragraph and full responses. So it continues until a stop condition is met, such as maximum length or special stopping rule or end of the sentence token. So through this iterative prediction loop, it maintains a context and the style across the long spans of the text. The next is coders and the copilots. So these are used for code generations. Example, LLMs excel at coding because the programming languages they are used to, it follows strict rules. And it makes the complex patterns easier for the model, and it reproduces accurately. So massive code data sets like GitHub repositories, the documentation, the libraries, and the Stack Overflows are the models are being trained using these kinds of data sets. And the tools used can be a GitHub Copilot or Code Whisperer or Gemini Code Assist, which can directly integrate into IDs like VS Code, PyCharm, and JetBrains. So they improve the developer productivity through automation, auto-completion, smart auto-completion. So it will predict the entire blocks of code or the entire functions. So they help in debugging by identifying the errors, and it fixes the errors and explains the error messages in simple language. It can also translate the code between the languages, making the modernization easier. So example, a Python can be converted into a JavaScript, a Java can be converted to mother language, and it can generate boilerplate code such as the API endpoints, the unit tests, the database schemas, and the repetitive configuration files. So these models accelerate the learning by provide step-by-step explanations, which helps the beginners how to code. So with proper prompting, the LLMs assist in optimization, documentation, and refactoring, and maintaining a large code bases. The next is, these are the different LLMs for the coding assistance. So these are the various LLMs for the coding assistance. The key features would be the learning patterns, training the data sets, then ID integration, auto completion, the boilerplate generation, the code translation, the refractions, the explanations, so refactoring, so and the documentation. These would be the key features. Then how AI is changing the software development. So AI, it acts as an assistant and increases the development speed. And it is not a replacement. And the routine tasks like syntax checks and searching documentation become automated and faster. And it gains more time to focus on the design of the system, the scalability, the creative problem solving, and the architectures. And it also catch bugs earlier by giving the code quality checks and the real-time debugging suggestions. The role of a developer evolves to include the prompt engineering, effectively communicating into AI tools, and collaborations become smoother as AI helps maintain the consistent coding styles. And code verification and validation, the developers must learn. ensuring the code is very secured, correct, and optimized. And overall, the AI turns the developers into a faster, more efficient, and high-level contributors rather than line-by-line coders. So understanding the embeddings. So this would be the foundation of the semantic search. So what is the embeddings? Where are we using it? What do you mean by embeddings? They are the numerical vector representations of the text, the images, the audio, or even the entire document. And it is being created by the neural networks. And they map the content into a high-dimensional vector space. So items with the similar meanings are placed, they are placed close together, even if the words used are different. Example, the embeddings allows the models to understand the semantic similarity, not just keyword matching. Example, a car equal to vehicle, apple equal to fruit. So they are essential for semantic search, enabling the search engine to find the relevant results based on the meaning and not the exact word. So semantic is we are going to search for the meaning and not as the similar to the syntax. So the key applications such as retrieval augmented generation, recommended systems, and the chatbots. They are the embeddings cover the key applications. These are the different applications, and they enable the LLMs to access the external knowledge, which will be up to date, the context aware, and more accurate data. So it allows the vector databases like FICE, Pinecone, Chroma, ViaWhite, and Melvis. It stores millions of embeddings, and these databases will perform fast nearest neighbor searches, and it will retrieve the closest vector, the most similar content in milliseconds. So this is the foundation of the semantic search, understanding the embeddings. So they are just the numerical vector representations of your text, the image, the audio, or even the entire document, but it is being created by the neural networks. The next is vector databases. So they are specialized systems. So they are going to, they can be used to search high dimensional embeddings. They are built to store, they're built to index, and they're optimized for similarity search rather than the exact meaning. So it uses the ANN approximate nearest neighbor algorithms to perform the fast similarity lookup among the millions and billions of vectors. Then it supports the real-time applications such as the recommendation engines, the chatbots, the personalization systems, and the anomaly detection. Then the popular examples includes the cloud native, the schema-based, and the lightweight developer-friendly Chroma. And the vector databases, they use the AI systems more accurate. It makes AI systems more capable of handling large amounts of repositories. So coming to the customized models, we can use the fine tuning where it modifies a pre-trained base LLM using a smaller data set. It will be a smaller data set, targeted data set, and relevant to a specific task or domain. And it allows the model to learn specialized knowledge, and it can teach, the developers can teach the model to a specific tone or a specific writing style or even the response pattern to their product or brand. Then it can be effectively used for domains like medical, legal, financial, customer support language. It is more cost efficient and faster. Then it requires fewer resources because it uses only a fewer parameters, smaller number of parameters, and the popular techniques would be LoRa, QLoRa, and adaptive tuning, which will reduce the training cost. And it outperforms the base models in accuracy, consistency, and the relevance within their targets. And it enables the organization to create the custom AI chatbots or automation tools or AI assistants. The next is SFT and RLHF. We are going to align the models to the human intent. So first would be the supervised fine-tuning called as the SFT. It is the first stage of the alignment where the model is trained on the high-quality question and answer data sets. So the goal is we teach the model how it should behave by providing direct demonstrations. And these datasets contain the ideal responses, which are written by specialists or the annotators. So it helps the model learn the tone, the correctness, the helpfulness, and the formatting. And it establishes the foundation and the outputs before advanced alignment stages. Next is RLHF, which is the reinforcement learning from the human feedback. So it uses the human evaluators for the same prompt who rank multiple model outputs. They are used to train a reward model that scores quality output. It is optimized using the reinforcement learning to prefer human approved responses and high rewards. Then it improves the model's safety, honesty, and refusal behavior. Together, we can say SFT and RLFT. It can make a better alignment with human values, human ethics, and user expectations. Coming to the alignment problem, why it matters. So, what is an alignment? It refers to ensuring that AI systems behave with proper human values, which is consistent with human ethics, intentions, and human values. And it is used to prevent the models from generating unsafe content. And the challenge exists from vast internet data, which may include toxicity and different misinformation. So it requires combining both the many technical methods like DPO, safety filters, SFT, RLHF with ethical frameworks. So it models these well-trained models, it can produce undesired outputs and making the alignments on ongoing process. And different organizations have different values and different cultures. So alignment must adopt to various companies with different values. So these training methods can be used to reduce the risks like bias, overconfidence, and harmful suggestions. And researchers use this continuously to refine the training methods. And this alignment is very useful for building the AI systems that are safe and reliable, especially for high-stake domains. So it is about this alignment is about ensuring that AI systems remain beneficial and under human control. Next is advanced alignment techniques. We are going to see about few advanced alignment techniques, which would be DPO, direct preference optimization. So it trains the model to prefer better responses. And it learns from the paired human preference data. And it uses a mathematical objective that aligns the models. And this seems to be more stable and sample efficient rather than comparing with the reinforcement. And it eliminates the problems caused by misalignment or overfitting, and it produces a smoother and predictable improvements in safety and helpfulness. And used in modern open source alignments, pipelines example, Z-File, install, instruct, etc. So becoming the preferred alignment method for developers, it's because of the lower cost and the simplicity. The next is RLAIF. This is the reinforcement learning from the AI feedback. So AI will judge instead of the humans. So what will RLAIF do? It replaces the human evaluators with a trusted AI model. So this reduces the cost and the time of collecting thousands of human labels, human preference labels. And this requires a human supervision only at the beginning to teach AI. The main LLM is trained using the reinforcement learning, which is similar to RLHF, but with AI-generated feedback. And then it allows the scaling alignments to millions of samples and helps bootstrap early stage alignments pipelines. It reduces the noise and inconsistencies and useful for training the models that need a repetitive evaluation criteria. Example, it can be used for coding, math, and safety tasks. Coming to the constitutional AI, this is called as the Anthropics method. So this is used for LLM self improvements can be used using the rules, and it is introduced by Anthropic to reduce the reliance on the human feedback. So this model criticizes its own output using the rules, and it generates improved responses. And this creates a data set of self-supervised corrections, making scalable alignments. And it encourages the model to follow ethical principles consistently and produces safer and more interpretable behavior across many domains. It is used heavily in Claude 2 and Claude 3 training. The next is content generation and communication. So LLMs transform how organizations produce and scale the communication. Number one, marketing automation. So it can use in marketing automation. It can create the social post, the product descriptions, and then it can promote the emails and generate ad copy, etc. It can be used in blog and article drafting, where you provide the outlines, then you create a long draft, and then optimized SEO content. In journalism assistance, so it can summarize the press releases, then it can convert your raw data into structured data and generate a factual draft. Email composition, you can write professional emails, then follow up sequences with consistent tone. Internal communications, you can produce meeting summaries, internal announcements, and documentation, and you can update the knowledge. Creative writing, so it can be used in character creation, narrative structuring for writers, supports in story ideation, report writing, automate the project updates, then automates the financial overviews, quarterly summaries. It can automate the business reports, etc. Speech and script writing. So you can generate the presentations, the video scripts, then you can generate the speeches according to the audience and styles. Then multimedia integration, you're going to combine your text and with the image, and it can be used for brochures, banners, marketing kits, etc. So this is how, so these are the different things we have talked about. So it can be used in, you can refine the scale and scale the communication. This is how your LLM transform how organizations produce, refine, and scale and communicate. So it can be used in marketing, journalism, internal communications, report writing, multimedia integration, creative writing, your email, and blog and article drafting. Coming to the productivity, automation, and the workplace efficiency. So different applications like email management. So email management, we write, we classify the incoming mails, then we see the urgent mails, we send the messages, we draft the responses, then we sort out the priorities. Then the next one would be the meeting productivity. So auto generation of transcripts can be done, highlighting, then follow-up tasks can be used. These tasks, then action items can be seen. You can do all this auto generation transcripts and follow-up tasks using the meeting productivity. Then knowledge retrieval, where you enable the staff to ask many questions to the natural language questions to search the company documents. So you are going to retrieve some information, knowledge. Then the next is the workflow automation. We are going to trigger that automatic tasks like scheduling, reminders, then ticket creation, report generation. So workflow automations can be done. Then code automation. So code, who is going to automate the code? And the developers are going to write the code. So you can assist the developers by fixing bugs, then reviewing code, then you can give some suggestions to the developers, then task prioritization. So daily we have many goals. So you can suggest daily goals, then reorder the task according to the priority, and then improve the personal productivity planning. Then template generation, you create the ready-to-use templates for the memos, agreements, HR letters, or some templates for proposals. So template can be generated. Then onboarding speed. So like new employees who join the companies, so it can help the new employees to navigate systems, the policies, and the procedures. So LLMs acts as AI copilots to reduce the manual workload and boost the employee productivity. So these are the various things the LLMs use for productivity, automation, and the workplace efficiency. So it's been given here. Then we come to the data analysis and the decision support. So LLMs democratize the data access. Then it makes accessible to the non-technical users. So number one would be the conversational data analysis. So the user can give prompts like show Q4 sales drop in charts. Conversational data analysis is being used by different users by typing some prompts. Then automated insights, it summarizes the trends, anomalies, the benchmarks, and summarizes everything, all the trends. Semantic search, so it is a combination of using the embeddings and the vector databases to search meaningfully across all the files. And rack systems, it combines the LLMs with the databases to provide accurate citation-based answers. Then it is used for fraud detection. It identifies the abnormal transactions using the patterns in large data sets. Risk analysis, so you can predict the risk and the market trends based on the structured and the unstructured data. And sentiment monitoring, it tracks the real-time sentiments across the news, the social media, the reports. Financial modeling, it generates the investment summaries or complex financial terminology. So interpret the balance sheets. It can be anything regarding to finance. Then data visualization, you convert the text into the charts or pivot tables or SQL queries or the dashboards. Just visualization data is being done. So it demonstrates all the data access, then it makes insights accessible even to the users who are not technical. The next is customer expertise and virtual agents. So this LLMs enhance the customer support and enable the AI-powered autonomous agents. So what would be the different customer support and AI autonomous agents? One would be the AI chatbots. So tier 1 customer queries such as the status checks, FAQs, the policy info, and the troubleshooting. 24/7 availability, it provides the immediate responses, improves the service quality, and it also doesn't use the user without the user intervention. The next would be the personalized interactions. So you can message, then you can give recommendation based on the user preferences and history. Then you can adapt the tones. Then virtual agents, it can complete all the tasks like updating the records and generating invoices and interacting with the websites. Cost reduction, it will reduce the staffing overhead when compared to the operations, customer service operations globally. Then multilingual support, so various real-time applications during the customer chats or calls. It provides the real-time translations. Then context retention, it maintains memories of previous interactions for more intelligent dialogues. Then quality monitoring, it analyzes calls, chats to ensure the compliance and detect the customer sentiment and the performance. So this LLMs will enhance the customer support and enable the autonomous agents. Coming to the creativity, learning, and innovation. So it creates a creative workflow, the scientific research and personalized education. So AI in education, where it can be used for personalized tutoring, then doubt clearing, session plan creation, and for practice questions. Then content creation for teachers, so they can be used for automatic generation of we can generate the quizzes, course materials, and assignments to the students. Then academic integrity challenges, so new assignments can be designed focusing on the critical thinking. And generative art, you can convert the prompts into the artwork using the Midjourney or Stable Diffusion or DAL-E. Music generation, you can produce the melodies, sound effects, produce background tracks, and even the voice cloning for the creators. Game development, you can generate your different games, character backstories, your textures, the 3D concepts, everything can be done. In scientific research, you can summarize about the different papers, the journals, the literature surveys, then highlight the trends, etc. Drug discovery, you predict, optimize the compounds, and then accelerate the lab analysis. And the last would be the virtual creativity partner. So they assist the writers, the musicians, the researchers, with constant ideation and the refinement. So these LLMs accelerate and help in the scientific research. Then they are used in personalized education, then scientific research, and creative workflows. So they are used everywhere, in arts, in music, in games, in scientific research, the drug discovery, then virtual creativity, and for teachers and integrity challenges, academic challenges, and everywhere. Then prompt engineering, it is a new skill where it is a practice of crafting the structured and strategic inputs to guide LLM's output. So it focuses main on the communication clarity, and it tells the AI exactly what you want. So prompts, it can act like instructions. So it can influence the tone, the accuracy, and the style of the response. Good prompts, it reduces the ambiguity, and it gives the necessary content for the model to understand what the task is about. Then it is essential in building the AI powered systems, then analytics tools and content generators and chatbots. And it enables the developers and the non-developers to leverage the LLM capabilities without the code changes. Ultimately, strong prompting ensures consistency, accuracy, and reliability across all the AI generated outputs. And it is more important as LLMs become a part of everyday's workflow in coding, in education, in marketing, research, and operations. So what are the best practices of the prompt engineering techniques? The role prompting. For example, you are a senior software developer. LLM as an expert, it improves domain-specific accuracy, and it provides and providing examples which teaches the model the expected format and the structure for the output using the few short prompting. So zero short prompting, they are used for simple tasks, very simple tasks, which infers the task from natural instructions. Then the chain of thought prompting, example, the model wants to think a step by step, enhancing the logical and the mathematical accuracy. In context expansion, you can add the background information or the definitions, and helps the model generate more precise responses. Instruction hierarchies, you're going to break the task into a numbered or bullet point instructions, so that it gives clarity to the users. Then refusal control, you can adding instructions like if you are unsure, say you don't know. So it reduces fabricated responses. Output formatting, requesting the tables, the bulletin points, and it also ensures the response is structured from the downstream tools. Iterative prompting, so it is this can be used for adjusting the prompts through experiments, which leads to optimal performance over time. So a formula for effective prompts. Role number one: Assigning a role. You are a cyber quest expert. This activates a domain-specific behavior and improves the accuracy. A formula for effective prompts is you are going to specify the role. Assigning a role. You are a teacher, you are a student, you are a developer, you are a Python developer, or you are a cyber security expert. So it activates the domain specific behavior, and you are going to define the task. You clearly define what the AI must accomplish. Example, you want to summarize, you want to translate, you want to analyze or generate or critique or design. What is the task? Then you talk about the context. So you give all the background information so that the AI does not guess the missing details. Constraints. You give limitations like word limit, what would be my reading level, or what the AI must avoid. You give the rules. Format. Specify the output structure. Example, if you want the bulletin points or the tables or the step-by-step reasoning, essay, code block, etc. Then you can give examples. You can give sample inputs and outputs, and you can teach the model what the result should be like. This is also a formula for an effective prompt. You give examples and you are prompting. And audience, mention who the output is. Like examples, who are the audience, whether the teachers or whether the students or the developers or the managers. You are going to give the audience, and you are going to shape the tone and the clarity, mentioning who the output is. Then quality expectations. You are going to include the directions like avoid repetition or verify the facts or be concise. Give the directions. Quality expectations should be given. And review the instruction, adding before answering. Check if your response follows all guides, improves the consistency. So just these are the various 9 formulas which says how you give a prompt. So you can give prompt by role, a task, a context, a constraint, a format, an example, an audience, and quality expectations and review instructions. Then how do you overcome this with the RAG? So RAG, what does it do? It connects the LLM to the various external sources, and it allows them to answer up-to-date information instead of relying on the memory. So the pipeline begins with a user query and then converted to an embedding for the semantic understanding. So it performs a vector search in the database. Examples could be Fias, Pinecone, Viavet, Chrome to find the most relevant documents. And only the most relevant pages are retrieved and passed along to the LLM as a context. And then it generates a strictly grounded in the provided documents, and it is used in enterprise applications, and it is used in organizations to combine the LLM reasoning with company specific knowledge without retraining the model. It is the foundation of the modern AI assistants and search engines and knowledge engines and chatbots. So this is how your RAG architecture looks like. You have the client and you have the framework, then you have the LLM, you have the prompts, the vector database. So you can see the questions is being asked to the framework, then LLM. It is being passed, the post-processing is being done, then the semantic search, the vector database is being accessed, the new content is available, the original content is being sent to the database, then the contextual data is sent to the framework. So the next is RAG architecture flow explanation. The client. So what is the, who is the client? It sends a question to the system and it receives the response. You are going to talk about the framework where the central engine is the framework which controls the workflow. So it sends the questions to the vector database and to the LLM. So LLM, it sends the question to the LLM for generating the final output, and it sends the question to the vector database for the semantic search. So what does it do? The framework, it will collect and it will post-process the LLM's response. The next would be the vector database. So it stores the document embeddings Then it performs the semantic search, and it returns the contextual data to the framework. Coming to the content source, it contains the original content, which will be in blue, and the new content, which will be in orange. So these are being converted to the vectors stored in the vector database. The next would be the LLM. So it receives the prompts and retrieved data, contextual data, and it sends the result back for post-processing, and it generates a accurate response. So what would be the overall flow? The client asks a question, the frameworks does the semantic search, the vector database, it does the relevant, gives the relevant context, the framework then gives a LLM prompt, the LLM generates the answer, the framework gives the final response to the client. This is how the overall flow of the LLM, like the RAG architecture, overall flow looks like this. Then why is RAG a game changer? Because of accuracy. It reduces the hallucinations because it relies on retrieved documents. Okay. Then domain adaptation. The organizations can add their knowledge without retraining the model. Then it is consistency. It gives it because of consistency, because of transparency, it allows showing citations or document source from each answer. Then it gives a repeatable factual results because the grounding data is fixed. Scalability, it's easily updated, and the model instantly becomes smarter, and the new documents can be added to the database. Then security, sensitive data is being it stays in your vector database, and cost efficient. Totally removes the need of expensive fine tuning for every knowledge update. Then multi-model ready, it works with your text, your images, your embeddings, enabling richer retrieval of the data, and also with the PDFs. So this is a game changer because of the accuracy, then the latest information it has, then the domain adaptation, then how it is consistent, the transparency, the scalability, the cost efficiency, the security, and the multi-model readiness. So how do you when do you switch? How do you give the difference between the RAG and the fine tuning? So RAG, it is the best for all the cases where knowledge changes often, and fine tuning is better when you want to modify the behavior. RAG, it adds the external data access, but fine tuning, it adds only the internal learning. RAG is faster, and it does not require any training. But fine tuning, it improves the consistency for the task. RAG ensures the factual accuracy, but fine tuning ensures a stylistic or a behavioral adaptation. And they are complementary, and they are not competitors. So many enterprises are going to use the systems together, like RAG for facts and fine tuning for a format or two. So fine tuning is better when you are going to modify the behavior or writing style of the model. Okay, so whenever you're going to use cases where knowledge changes often, you can go for RAG. So this is how you can use a RAG and fine tuning according to the situations. So deploying LLMs, what would be the challenges? You have the latency issues, it requires heavy computation, and it will cause slower responses without an optimization. Then inference cost, it is more expensive rather than training. Scalability, several millions of users requires the distributed inference systems. Then memory footprint, large models require 20 to 400 GB VRAM depending upon the size. Then traffic spikes, it must handle unpredictable load safety. Then cold starts, delay when spinning up of GPU affects the user experience. Then model complexity, so the more bigger model you use, it will require the optimized hardware. Then consistency, you are going to like maintaining the outputs across the versions, various versions is highly difficult. Regulation, deployment may need compliance with the data security and the privacy laws. So these would be the various challenges of deploying the LLMs, which includes all the 9 features. So coming to the efficiency and the optimization, so the quantization, distillation, pruning, catching, patching, speculative decoding, LoRa, QLoRa, and tensor parallelism and KV catch optimization. So this model weighs reducing the memory and the speed. And then distillation, it creates a student model that mimics a large teacher, offering the near similar performance. Then it removes the redundant neurons to reduce the size. Then it saves the previous embeddings or the responses, and it avoids the repeated computation. Batching, it the process multiple requests at one, so that the GPU utilization is maximized. Then it is a small model to predict the tokens. Then a lightweight fine tunings can be done that keeps the base model frozen. Then splitting the model layers across the GPU for faster inference. Then it reduces the repetitive attention computation during a very large conversation. This is about the optimization and the efficiency. Coming to the infrastructure, so cloud or coming to the we talk about the GPU solutions, cloud versus on-prem. So cloud GPU solutions, it can be either AWS or Azure or GCP, provide on-demand scalable GPU clusters. On-prem deployments offers full control over the data and security. Cost factor, the cloud reduces the upfront cost, and on-prem requires higher initial investment maintenance. The cloud updates, and the on-prem requires in-house expertise. Coming to the scalability, it's the cloud scales instantly, and this on-prem requires hardware expansion. Complaints on-prem is often preferred for regulated industries like government, banking, healthcare, etc. Then hybrid architectures, many companies combine the different cloud scalings with on-prem sensitive data handling, networking. High-speed connections are crucial for the large models on models. Energy costs, on-prem GPU clusters the required significant power and cooling. So this is about the infrastructure, cloud versus on-prem. So APIs versus the open source models. So API models would be the OpenAI, the Anthropic Gemini. So it is easy to use and set the text and get the results immediately. So what would be the different pros? You don't have to, no need to manage the GPUs. It is always updated, and higher quality frontier models. It gives highest quality. Vendor lock-in limits the flexibility, then per token cost grows with the usage, then data privacy concerns depending on the terms. The next is open source model like Llama, Mistral, Falcon. They are fully customizable and deployable anywhere. So what would be the pros? There will be no API cost, recurring API cost. Then the ability to fine-tune or modify the internals, full data model on-prem or private cloud. So the cons would be requires GPU setup and maintenance. Then quality might be slightly lower than the frontier models. Talking about the use cases, APIs for rapid prototyping, and the open source for enterprise private systems. The hybrid strategy, many organizations use the APIs for open source models for the production. And about the flexibility, it gives more freedom for custom architectures like fine tuning, RAG, safety layers, etc. So coming to the open source models, Llama, Mistral, Gemma, Quinn, Phi, etc. So pros are full data control and privacy. You decide where the model is, and it is ideal for sensitive industries like health, government, private, etc. And highly customizable. It can be fine-tuned depending upon your specific data sets. Then a lower long-term cost. So after deployment, you are not going to have any recurring API fees for every request. Then talking about the offline or on-prem deployment, It works even without internet and suitable for restricted environments. And talking about the transparent ecosystem, it has access to the model weights, training details, the research papers, etc. So coming to the cons, it requires infra and MLO piece expertise. So skills in GPUs, Docker, Kubernetes, quantization exercise required. Then significant hardware requirements, like a larger model needs high-end GPUs for inference and training. So lower initial setup compared to plug and play commercial APIs. It's a lower initial setup. So you have more cons or pros rather than the cons. So it is for full data, control privacy, and highly customizable and lower long-term cost and offline on-prem deployment and transparent ecosystems. Coming to the hybrid approach, it combines the attention of the commercial LLMs with the flexibility of the open source. So it can be used for advanced coding, then natural language generation, multimodal task, which combines the image, text, and the audio. Then it can be used for open source models where repetitive internal for repetitive internal workflows for fast sensitive data requiring on the privacy, can use for classification, summarization, and the chatbots. And it can be used for domains, specifically fine-tuned domain models like enterprise, legal, medical, etc. Benefits is it's going to give you a lower cost, higher privacy, and optimal performance for each task. So essential development frameworks for modern AI, you talk about the LangChain, Llama Index. So these are the frameworks for building the RAG pipelines, then multiple agent systems, the workflow, orchestration, like then context-aware chatbots, and handling embeddings, retrieval chains memories. Then what would be the various essential development frameworks for modern AI? You talk about the Hugging Face, where it can be used for largest hub. It is the largest hub for the open source training scripts and spaces for demos. Then spaces for training scripts, etc. And it provides the transformers, the accelerates, and different inference endpoints. The other usual tools would be the Olama, which runs locally. Then you talk about the TGI, which is the high-speed LLM interface servers. Then Pinecone or Milvus, it is a vector database for RAG, and weights and biases, which is used for experiment tracking. So these are the different tools, essential development frameworks for the modern AI, just listed here. So the working flow has been described. And coming to the machine learning operations, we have the purpose, like full life cycle of AI or LLM model can be used in the production. And new MLOPs needs for LLMs would be the prompt versioning. You can use it for quality monitoring. You can use for multiple models in production. And the key responsibilities would be monitoring the prompt, the model drift, the data drift. Then you can measure the quality output, then for cost optimization, then model deployment. So these are the various key responsibilities. And the next, so we are ending up the session now. So I have few generative AI and LLM quiz. I have around 50 questions. And all these 50 questions will have the answers at the end of my slide. So I'll tell the host, I'll tell the college management to share the slide to you. So you can have a general view on all these questions, and the answers are given below. You can check your knowledge. This. Thank you, ma'am.
Participants, you can post your queries if anything is available in the Zoom chat box. We will send you the material through YouTube, ma'am.
Yes, sir, sure.
Yeah, yeah, yeah. Participants, if you have any queries, you can post it in the Zoom chat box. Or you can unmute and you can ask the question. Participants, any queries is there? Okay, then we'll wind up, ma'am.
Yes.
Thank you so much, Dr. M.V. Aishwarya ma'am, for the deeply insightful and enlightening session. Your expertise has certainly enriched our understanding and expanded our perspectives, ma'am. So, as we
Yes.
come to the close of this intellectually stimulating session, it is time to express our gratitude. I now invite Ms. Mahabub Nisa, Assistant Professor, to deliver the vote of thanks, acknowledging everyone who made today's program a grand success. Over to you, ma'am.
Okay, sir. Good evening to everyone present here. It is my privilege and honor to deliver the vote of thanks on this wonderful occasion of the Faculty Development Program. On behalf of the organizing committee, the management, and the entire institution, I extend my heartfelt gratitude to all who have contributed to the success of this program. First and foremost, I would like to express a deep sense of appreciation to our resource person, Dr. Aishwarya, MB, Professor and HOD of Artificial Intelligence and Data Science Department, Agni College of Technology, OMR Chennai, for taking time from your busy schedule to share your valuable insights and expertise in generative AI and large language models, LLMs, with us. Your thought-provoking sessions and practical perspectives have enriched our knowledge and inspired us to enhance our academic and professional approaches. We are deeply a very, very informative session, ma'am. Thank you, ma'am. We are deeply grateful to our director, Dr. M. Usha, for constant encouragement, guidance, and support in organizing this program. Your leadership continues to motivate us to strive for excellence in every endeavor. A special thanks to our HOD, Mr. Special thanks to our HOD ma'am, Dr. MD Vimlapriya, for her constant support, motivation, and leadership that made this program possible. We are truly grateful for your visionary leadership. A special thanks to all the resource persons whose knowledge sharing and interactive discussions have contributed immensely to the success of this FDP. I'd also like to thank the organizing committee, supporting staff for their dedication, coordination, and behind the scene efforts that ensure smooth conduct of every session. A sincere thanks to all the participants and faculty members who actively participated, interacted, and made this program meaningful. Your enthusiasm and involvement have truly been encouraging. We also appreciate the efforts of our technical team and support staff who ensured a seamless digital expertise throughout the program. Lastly, I extend my gratitude to everyone directly and or indirectly associated with this program. Without your support, this event would not have been possible. Thank you, one and all. Looking forward to meeting you again in future academic endeavors. Have a wonderful day ahead. Thank you. Thank you so much.
Thank you, ma'am, for the heartfelt words of appreciation. Participants, the day two feedback and attendance link is shared in Zoom and YouTube chat box. We can fill it out. With this, we officially conclude today's the day two session of the International FDP. We thank all participants, speakers, and organizers for the time and support. Stay connected, stay inspired, and we look forward to meeting you in the upcoming sessions. Thank you.
Thank you, sir.
Participants, the day two feedback come attendance link is shared in the chat box of both Zoom and YouTube as well. So kindly fill it for your certificate purpose. No, sir. No mail will be given for you as a confirmation, sir. Dr. Pushpalata Singh.
We, sir, will end the session, sir.
Yes, sir. Okay, okay, sir.